A distant island universe holds 50 cosmic secrets. The Sombrero Galaxy is not just a beautiful spiral, it is a treasure chest overflowing with bizarre objects that defy simple explanation. By the end of our journey, you will have a front row seat to the most peculiar collection of phenomena ever discovered in a single galaxy. We will encounter a black hole with a strange appetite and a star cluster fleeing its home. What cosmic violence could warp an entire galaxy's dust lane into a tilted ring? What do you think is the most surprising thing a galaxy can hide? At the very heart of the Sombrero Galaxy lies a gravitational monster of almost incomprehensible scale. This supermassive black hole is not merely large, it is an anomaly, a cosmic paradox that challenges our understanding. While most galaxies host a central black hole, the one within the Sombrero is a true behemoth with an estimated mass of around 1 billion times that of our own Sun. To put that into perspective, the black hole at the center of our Milky Way is a mere featherweight in comparison, a fraction of that staggering size. This immense gravity creates a whirlpool of space-time, warping the very fabric of the cosmos around it. The strangeness begins with the black hole's appetite. It is not actively consuming vast amounts of material, which is unusual for an object of such power. Instead, it seems to be in a state of quiet contemplation, a sleeping giant. Yet, the effects of its presence are undeniable and dramatic. Surrounding the black hole is a brilliant, swirling disk of superheated gas and dust known as an accretion disk. This disk is not a flat, orderly platter, but a chaotic, luminous maelstrom where matter is accelerated to near light speed, glowing with intense radiation before it vanishes forever past the event horizon. Even more bizarre is the phenomenon of gravitational lensing. The black hole's gravity is so powerful that it acts like a cosmic magnifying glass, bending the very light from stars and galaxies behind it. This creates distorted, multiple images and strange arcs of light, a ghostly mirage in the depths of space. It is as if the black hole is showing us a funhouse mirror version of the universe, twisting reality itself. How can an object so massive and influential remain so relatively quiet? What cosmic mechanisms are at play that keep this leviathan in a state of such deceptive calm? The answers may lie not with the black hole itself, but with the other strange objects that share its galactic home. But the central black hole is not the only secret hidden in the galaxy's bright core. Peering deeper into the Sombrero's brilliant heart, astronomers have uncovered a puzzle that defies simple logic. High-resolution observations suggest the galaxy might not have one but two nuclei. This is the twin nucleus mystery. It is as if a cosmic architect designed a building with two separate foundations, a structural oddity that should not exist. One nucleus appears slightly offset from the very center, a second glowing knot of stars nestled within the primary bulge. How can a galaxy have two hearts? The evidence comes from meticulous analysis of the light emanating from the core. The data reveals two distinct brightness peaks, two centers of stellar density where there should logically be only one. One leading theory proposes a violent galactic merger in the distant past. Perhaps a smaller galaxy was cannibalized by the Sombrero, and its own core, stripped of its outer stars, now orbits forever within its captor. Another, more exotic idea suggests that our view is being tricked by a bizarre cosmic alignment. A thick, dark ring of dust circles the galaxy's center, and it is possible we are seeing a single, elongated nucleus whose middle is obscured, creating the illusion of a twin. The light we detect could be the two visible ends of a single, bar-shaped structure, with the connecting part hidden in shadow. This would be like seeing only the two ends of a pencil held behind a book. Yet the data remains tantalizingly ambiguous, keeping the true nature of the Sombrero's core one of its most profound secrets. What other illusions might this galaxy be crafting right before our eyes? This galactic sleight of hand extends far beyond the core. As astronomers scanned the Sombrero with instruments sensitive to invisible light, they stumbled upon two enigmas known only as IR-1 and IR-2. These are not stars or planets as we know them, but colossal, unidentified sources of infrared radiation glowing with an unexpected and puzzling heat. They are cosmic ghosts visible only in the thermal signature they leave behind. The first great mystery is their sheer, unexpected brightness. In the cold expanse of space, such intense infrared glows usually signal one of two things: either a furious nursery of newborn stars shrouded in dust, or the heated debris surrounding a single colossal object. But here, the simplest explanations fall short. If these were stellar nurseries, we would expect to see other telltale signs, specific wavelengths of light that are conspicuously absent. If they were the aftermath of a single star's explosive death, the remnants do not fit the known patterns. This leaves astronomers contemplating more exotic origins. Perhaps these are vast, chaotic clouds of exotic dust, a type of cosmic material that absorbs starlight in a unique way and re-radiates it as this strange, pervasive warmth. Or maybe they are the signatures of processes we have not yet even named, phenomena occurring in the dense, obscured regions of the galaxy where normal telescopes cannot peer. The very fact that they are listed simply as infrared sources highlights their mystery. They are cosmic question marks written in the language of heat. What other invisible phenomena are hiding in plain sight, waiting for us to develop the right eyes to see them? Far from the galaxy's warm heart, drifting in its cold outer halo, we find a different kind of mystery. Orbiting the Sombrero are three ancient star clusters known only as GCX-1, GCX-2, and GCX-3. On the surface, they appear to be typical globular clusters, dense spheres of hundreds of thousands of ancient stars. But a closer look reveals they are cosmic interlopers, strangers in a strange land. Their very existence tells a story of galactic violence. While most of the Sombrero's globular clusters are ancient and metal-poor, meaning they contain very few elements heavier than hydrogen and helium, these three are different. They possess a surprising abundance of these heavier metals. This is a crucial clue. Stars forge heavier elements in their cores and scatter them into space when they die. A cluster rich in metals suggests it formed from gas that had already been seeded by multiple generations of earlier stars, a process that typically happens in the crowded, chaotic disks of large galaxies, not in the sparse, primordial halo. The orbits of these three clusters are equally strange. They move around the galactic center on highly elongated, inclined paths, unlike the more circular orbits of the native clusters. This is the celestial equivalent of someone walking against the flow of a crowd. These three clusters did not form here. They are survivors, the captured cores of smaller galaxies that were torn apart and devoured by the Sombrero billions of years ago. Each one is a ghost of a galaxy that no longer exists, a dense, resilient heart that refused to be digested. Their unusual chemistry is a fossil record of their original homes, and their chaotic orbits are the scars from that ancient cosmic feast. What other galactic echoes are still whispering to us from the darkness? The metal-rich survivors in the halo are not the only evidence of the Sombrero's hidden structure. Surrounding the entire visible galaxy is an immense and invisible presence, a cloak of dark matter that holds everything together. This halo is the galaxy's true skeleton, a framework of gravity woven from a substance we cannot see or touch. Its existence is not just a theory, it is a necessity. When astronomers measure how fast the stars and gas on the galaxy's outer edges are rotating, they encounter a profound mystery. According to the laws of gravity, these distant objects should be moving much more slowly, like planets on the far fringes of a solar system. Instead, they whip around at velocities that should send them flying off into intergalactic space. The only thing preventing this cosmic disintegration is the immense gravitational pull of unseen mass, a vast reservoir of dark matter. The strangeness of the sombrero's halo lies in its shape and distribution. For many galaxies, the dark matter forms a relatively smooth spherical cloud, but here the evidence suggests a more lopsided and lumpy structure. There are gravitational anomalies, pockets where the tug of gravity is stronger or weaker than expected, as if the invisible skeleton has dense bones and empty cavities. This uneven pull warps the motions of the visible stars and gas, creating subtle tugs and twists that would otherwise be inexplicable. Imagine trying to understand the shape of an object hidden under a blanket by only watching how the blanket sags and bulges. That is precisely what astronomers are doing. They map the gravity of the unseen by carefully tracing the paths of the seen. This dark matter halo is not a passive container. It is an active sculptor, dictating the speed of the galaxy's spin and influencing the fate of everything within its grasp. What other invisible forces are dictating the dance of the cosmos, completely unseen by our most powerful telescopes? This tilted ring of dust is the Sombrero Galaxy's most defining and peculiar feature. It is not a flat, orderly disk like the rings of Saturn, but a dramatically warped structure that cuts across the brilliant bulge of stars at a sharp angle. From our vantage point, this dark band gives the galaxy its iconic sombrero appearance, but its true nature is far more dynamic. This is not a static decoration. It is a cosmic whirlpool in slow motion, a vast collection of gas and dust grains swirling in a profound gravitational dance. The ring's pronounced warp is a fossil record of gravitational disturbances. One compelling explanation points to a past encounter. A smaller satellite galaxy may have made a close pass billions of years ago, its gravity tugging on the delicate disk of material, twisting it out of its original plane and setting it at this permanent tilt. The ring did not snap back, it simply settled into this new, unstable equilibrium. But the influence is not only from the past. The immense gravity of the central supermassive black hole and the galaxy's own lumpy dark matter halo continue to exert their pull, creating complex forces that constantly work upon the dust. Within this dark lane, the raw material for new stars is constantly churning. Dense knots of gas collapse under their own weight, igniting into brilliant new suns, their light initially hidden by the very dust clouds that created them. This delicate balance between creation and obscuration is on full display. The warped dust lane is therefore both a museum and a nursery, a relic of ancient violence and a cradle for future stellar generations. What other stories are written in the silent, dark twists of cosmic dust? Floating within the sombrero's vast expanse is a cosmic projectile, a titanic cloud of gas hurtling through space at speeds that defy simple explanation. This is not a gentle drift, it is a violent rush, a tempest moving faster than the galaxy's own rotation. The cloud is immense, containing enough material to form millions of stars, yet it travels as a single, chaotic entity. Its movement is so rapid that it should be tearing itself apart, yet some invisible force or its own sheer momentum holds it together. The origin of this high-velocity cloud is a subject of intense debate. One compelling theory points back to the galaxy's violent history of mergers. This cloud could be the final, gaseous scream of a devoured dwarf galaxy, a shred of its atmosphere ripped away during the collision and sent careening through its new host. Another, more dramatic possibility is that it is the debris from a colossal stellar explosion, a supernova of such unimaginable force that it blasted a gigantic bubble of gas clear out of the galactic disk, sending it racing into the halo. As this cosmic cannonball plows through the sombrero's interstellar medium, it creates a ripple effect of chaos. The cloud acts like a snowplow, pushing aside and compressing the thinner gas that already exists between the stars. This compression can trigger unintended consequences, squeezing cold, quiet regions of gas until they reach a critical density and suddenly collapse to birth new stars. In its wake, the cloud leaves a turbulent trail, a region of heated and stirred-up gas that will take millions of years to settle. It is a destructive force that inadvertently becomes a creative one, a testament to the dynamic and often violent cycles of galactic life. What other invisible bullets are silently crossing the depths of space, their passage marked only by the ripples they leave behind? Even the fastest cosmic cannonballs cannot compare to the raw power emanating from two specific points deep within the galaxy. Designated as ULX-1 and ULX-2, these are not your typical stellar beacons. They are ultraluminous X-ray sources, each pouring out more X-ray radiation than 1 million suns emit across all wavelengths combined. Their brilliance is so extreme that it defies the standard limits of physics for known objects. For decades, such incredible output was thought to be the exclusive signature of supermassive black holes at the centers of galaxies. Yet here they are, out in the galactic suburbs, shining with a ferocious intensity that has astronomers locked in a passionate debate. What kind of cosmic engine could possibly generate such staggering power? The leading theory points to a long-sought missing link in the black hole family, an intermediate mass black hole. These would be the elusive middleweights of the cosmos, more massive than the black holes formed from single collapsing stars, but far smaller than the supermassive giants at galactic centers. A black hole of this class, with a mass of a few thousand suns, could theoretically devour matter at a voracious rate, heating the infalling gas to incredible temperatures and glowing with the intense X-rays we observe. But there is a compelling and strange alternative. What if these are not black holes at all? They could be neutron stars, the incredibly dense, city-sized cores of exploded stars operating in a way we once thought impossible. A typical neutron star has a strict upper limit to its brightness, a point where its own intense radiation should push away any further material, effectively turning off its own fuel supply. Yet ULX-1 and 2 blast right through this theoretical ceiling. This suggests a neutron star with an unbelievably powerful magnetic field, one that shapes the infalling gas into orderly columns that funnel directly onto its magnetic poles, allowing it to violate the usual rules and shine with ultraluminous fury. The very existence of these objects forces us to reconsider the fundamental mechanics of how matter behaves under extreme gravity. Are we looking at the birth of a future supermassive black hole, or witnessing a magnetically gifted neutron star performing a feat of cosmic strength? The answer remains locked within those brilliant, flickering points of X-ray light, challenging our understanding of the universe's most powerful engines. This runaway star cluster is a cosmic fugitive, fleeing the galactic core at a speed that defies gravity's grasp. How does an entire family of stars, bound together for billions of years, get thrown out of its home? The mechanism behind this great ejection is as violent as it is precise. One leading suspect is the gravitational slingshot effect, a celestial maneuver of immense power. Picture the dense core of the Sombrero Galaxy, a crowded space dominated by the supermassive black hole and a tight swarm of ancient stars. If a binary star system, two stars orbiting each other, wanders too close to the central black hole, a gravitational dance of chaos can unfold. The black hole's immense gravity can tear the binary pair apart, capturing one star into a tight orbit while violently flinging the other away at tremendous speed. If this ejected star was itself the central anchor of a globular cluster, the entire cluster could be hurled outward, becoming a runaway on an irreversible journey into the intergalactic void. Another, even more explosive possibility involves a supernova cascade. Within a densely packed cluster, multiple massive stars could reach the end of their lives in rapid succession. If one star explodes as a supernova, the sudden, asymmetric loss of mass can act like a natural rocket engine, giving the entire cluster a powerful kick. If several supernovae occur in just the right way, their combined force could provide enough thrust to overcome the cluster's gravitational bond to the galaxy, ejecting it entirely. This runaway cluster is more than just an anomaly. It is a fossil record of the extreme forces at play in the galaxy's most crowded regions. What other celestial projectiles have been launched from the Sombrero, destined to wander the dark spaces between galaxies forever? Deep within the Sombrero's spiral arms, a single star pulses with a rhythm that is subtly wrong. This Cepheids variable, a cosmic metronome used for over a century to measure the vast distances of the universe, is beating out of time. Its light rises and falls in a predictable cycle, but the period of its pulsation and its inherent brightness are out of sync with every established model. This is not a minor discrepancy, it is a fundamental challenge to one of astronomy's most trusted tools. Cepheids variables are the mile markers of the cosmos. Their secret is a direct relationship between how long it takes them to pulse and their true, intrinsic brightness. By measuring the pulse rate from Earth, astronomers can calculate the star's actual luminosity. Then, by comparing that calculated brilliance to how dim the star appears from our vantage point, they can determine its distance with remarkable precision. This method has been foundational, helping us map the scale of our own galaxy and beyond. But this anomalous Cepheids in the Sombrero defies the formula. A star with its particular pulse period should shine with a specific, predictable wattage. Instead, it is either too dim or too bright for its rhythm. This throws its entire distance measurement into question, and by extension, raises a faint shadow of doubt about the Sombrero Galaxy's precise placement in the cosmos. What could cause such a reliable standard candle to flicker incorrectly? The answer may lie in the star's unique environment or its own complex history. Perhaps it is a much younger Cepheids than we assume, still settling into its stable pulsating phase. Its internal structure, the layers of burning hydrogen and helium, might be arranged in an unusual way, altering its heartbeat. Another possibility is that the star has a hidden companion, a faint stellar partner whose gravity subtly tugs on the pulsating giant, distorting its rhythm. Or maybe the chemical composition of this particular star is different from the Cepheids we use to calibrate our models. If it formed from gas that was richer or poorer in heavy elements, its physics would operate by a slightly different playbook. This one anomalous star is a single discordant note in a cosmic symphony, reminding us that our models are built on averages and assumptions. Its very strangeness is a probe, revealing the hidden complexities of stellar evolution and the subtle variations that can exist from one galaxy to the next. What other cosmic constants might be mere guidelines, waiting for the right strange object to challenge them? Floating far beyond the Sombrero's spiral arms, 3 points of light form a celestial triangle so perfect it defies coincidence. These are quasars, the brilliant, active hearts of unimaginably distant galaxies, each one powered by a voracious supermassive black hole. Designated QSC1, QSC2, and QSC3, their close and symmetrical alignment is a puzzle of cosmic geometry. The fundamental question is starkly simple. Are we seeing a miraculous chance alignment of 3 separate, unrelated objects? Or is this a single quasar whose light has been split into a triple image by a massive foreground object? The odds of 3 quasars, which are themselves incredibly rare, lining up so perfectly by pure chance are astronomically low. This makes the gravitational lensing explanation profoundly compelling. In this scenario, a colossal mass, perhaps an entire cluster of galaxies, sits between us and a single, distant quasar. The immense gravity of this foreground cluster warps the fabric of space-time, bending the quasar's light around it like a giant lens. This creates multiple pathways for the light to travel to our telescopes, resulting in the 3 distinct, magnified images we see. The implications of this being a true triple lens are staggering. It would act as a natural telescope, allowing us to study the distant quasar in far greater detail than would ever be possible on its own. We could probe the structure of its accretion disk, measure the mass of its central black hole with unprecedented precision, and even map the distribution of mysterious dark matter in the foreground lensing cluster. The precise positions and brightness of the three images are a direct map of the lens's gravitational field. But if further observation proves this is a genuine triple quasar system, three separate active nuclei existing in close proximity, the cosmological implications are even more explosive. It would suggest a region of the universe of unprecedented density, a cosmic traffic jam where three giant galaxies are simultaneously feeding their central black holes, all while spiraling toward an eventual collision. Such a find would challenge our models of how large-scale structures form, hinting at pockets of the early universe where matter was concentrated in ways we are only beginning to understand. This triple configuration, whether an illusion of light or a genuine trio, forces us to question the very texture of the cosmos and the hidden masses that shape our view of it. This strange Cepheid's irregular beat is echoed by a much larger cosmic rhythm. Wrapping around a portion of the Sombrero Galaxy is a colossal loop, a ghostly structure only visible to radio telescopes. This is the radio loop, an ethereal ring of energy that dwarfs entire star clusters, tracing a faint circle against the darkness. It does not emit the familiar light of stars, but instead whispers its existence through the faint crackle of radio waves, the same kind of energy used for broadcasting, but generated on an unimaginable scale. The loop is a fossil of immense power, a scar left by a violent event that rocked this region of the galaxy eons ago. One compelling hypothesis points to a titanic stellar explosion. A supernova of extraordinary force could have blasted a spherical shell of material and energy outward at fantastic speeds. As this expanding bubble of hot gas and magnetic fields plowed into the surrounding interstellar medium, it would have compressed and energized it, creating the very conditions that cause radio waves to be emitted. What we see now as a loop is likely just a two-dimensional projection of a three-dimensional shell, a bubble so vast we are only seeing its brightest, most defined edge. But the sheer scale of this structure raises another, more dramatic possibility. This loop could be the remnant of a past galactic outburst, a time when the central supermassive black hole was anything but quiet. In a brief but ferocious feeding frenzy, the black hole could have belched out colossal jets of energetic particles. If one of these jets happened to punch through the galactic disk at a shallow angle, it could have created a massive, ring-like shockwave as it interacted with the galaxy's gas, a ripple in the cosmic pond that persists as this faint radio echo. The loop is a silent monument to the galaxy's active past, a reminder that the current calm is likely just a pause between tempests. What other invisible structures are waiting to be heard, their stories told not in light but in the silent songs of radio static? A single, ancient giant star burns in the Sombrero's halo, a stellar relic with a chemical fingerprint that should not exist. Catalogued simply as a metal-rich giant, this star is a profound cosmic paradox. It is incredibly old, a first-generation survivor from the galaxy's infancy, yet its atmosphere is laced with a surprisingly high abundance of heavy elements like iron and silicon. This is the stellar equivalent of finding a prehistoric cave painting that used synthetic factory-made pigments. For astronomers, this single point of light presents a riddle that forces us to rewrite the early history of the entire galaxy. The very first stars in the universe were behemoths made of pure hydrogen and helium. They lived fast, furious lives, and when they died in colossal supernova explosions, they forged the first heavy elements in their cores, seeding the cosmos with the raw materials for everything to come, including planets and life itself. Subsequent generations of stars formed from this enriched gas, each one inheriting a richer chemical legacy than the last. Therefore, a truly ancient star should be metal-poor, a pristine record of the universe's primordial state. This star's advanced age is undeniable, confirmed by its position on stellar evolution charts and its faint, cool glow. Yet its high metallicity defies this simple timeline. How could a star so old become so enriched? The answer points to a surprisingly chaotic and efficient start for the Sombrero Galaxy. This giant may not have formed in a slow, isolated cloud. Instead, it could have been born in an incredibly dense and turbulent region, a stellar nursery located right next to the galaxy's earliest supernova. The first massive stars would have exploded almost instantly in a cosmic blink, their freshly forged elements flooding the nearby gas clouds before the next round of star formation even finished. This star, then, is a product of that rapid, localized pollution. It incorporated the ashes of its massive, short-lived neighbors before it had even finished condensing. Its unusual chemistry is a frozen moment from a time of frantic galactic construction, when the first heavy elements were churned out and mixed into new stars with surprising speed. This single star forces us to reconsider the Sombrero's fiery birth, suggesting it was not a slow and stately gathering of gas, but a violent, explosive adolescence that enriched its stars far sooner than anyone predicted. A ghostly bubble of energized gas hangs in an unexpected void, a displaced supernova remnant drifting far from the galaxy's vibrant stellar nurseries. This is the aftermath of a star's catastrophic death, a luminous shell expanding into the darkness, but its location makes no sense. Supernova mark the violent end of massive, short-lived stars, and such stars are born in the dense, gaseous spiral arms. They do not have time to wander far from their birthplaces before they explode. Yet here this remnant sits, isolated in a quiet, sparsely populated region of the galaxy, a cosmic crime scene with no body in sight. How did the star that created this chaos die so far from home? The leading theory involves a stellar fugitive, a runaway progenitor star. Imagine a massive blue giant born in a crowded cluster within one of the Sombrero's spiral arms. Through a gravitational encounter, perhaps a close pass with another massive star or even the cluster's core, this star could have been flung outward at tremendous speed. For the few million years of its remaining life, it would have traveled across the galaxy like a lit fuse, a ticking time bomb racing through the void. When it finally went supernova, it detonated in the middle of nowhere, leaving behind this orphaned remnant as the only evidence of its dramatic escape. The expanding shell of debris now reveals the composition of the exploded star, its chemical fingerprints flung into the emptiness, but there is another, more unsettling possibility. What if this remnant is not the product of a runaway star at all, but a witness to a stellar population we have completely missed? Could there be faint, ancient pockets of star formation hidden throughout the galaxy's halo, regions so dim and diffuse they have escaped our notice? These could be the last remnants of the satellite galaxies the Sombrero consumed long ago, their final stars flickering into oblivion. A star from one of these hidden populations could have lived and died in place, its supernova remnant appearing as a lone sentinel in the dark. This displaced object forces us to question the completeness of our galactic maps, hinting that the Sombrero's history is written not just in its bright arms, but in the silent explosions echoing from its forgotten corners. Two faint, ghostly rivers of stars flow silently through the Sombrero's outer halo. These are tidal stream S1 and S2, the final, fading signatures of dwarf galaxies that no longer exist. They are the galactic equivalent of footprints in wet sand, slowly being washed away by the tide of time. These streams are not random collections of stars, they are the stretched-out remains of entire systems, torn apart over billions of years by the Sombrero's immense gravity. As a smaller galaxy ventures too close, the difference in gravitational pull between the side nearest the Sombrero and the side farthest away becomes overwhelming. This tidal force stretches the galaxy like cosmic taffy, pulling stars and gas from its body and scattering them into long, arching ribbons that trace the victim's original orbit. S1 and S2 are two such ribbons, the final breaths of two separate galactic encounters. Their importance goes far beyond confirming a violent past. They are powerful tools for mapping the invisible. The shape, density, and path of these stellar streams are exquisitely sensitive to the gravitational field through which they travel. Any lumps or gaps in the streams, any subtle bends or kinks in their trajectories are not random. They are direct responses to the distribution of dark matter in the sombrero's halo. Imagine dropping a handful of fine sand onto a sheet of velvet laid over a series of hidden objects. The sand will settle into a pattern that reveals the bumps and shapes beneath the cloth. S1 and S2 are that sand, and the dark matter halo is the hidden structure. By meticulously tracking the motions of stars within these streams, astronomers can reconstruct the gravitational forces that molded them. A slight condensation of stars might indicate the stream passed through a denser knot of dark matter, while a thin, stretched-out section could mean it traveled through a relatively empty void. This allows scientists to create a three-dimensional map of the invisible skeleton that holds the entire galaxy together, a task that would be nearly impossible by any other means. These faint streams are therefore more than just fossils. They are active probes, charting the contours of the universe's greatest mystery. What other secrets about the dark cosmos are written in these fading stellar rivers, waiting for us to learn how to read their slow, silent dance? A silent beacon of pure energy pulses from the sombrero's depths, a source of gamma rays so powerful they dwarf the visible light of entire star systems. This is the orphan, a brilliant signal with no identifiable source. It announces its presence in the most energetic language the universe possesses, yet when we turn every other telescope toward its location, we find nothing but empty space. There is no bright star, no swirling disk of gas, no remnant of an explosion, only this insistent, invisible shout. The orphan is a cosmic paradox, a voice crying out in the dark with no visible body. The hunt to identify it revolves around three compelling yet deeply strange possibilities. It could be a pulsar, the rapidly spinning core of a dead star, but one hidden by an unimaginably thick shroud of dust. A typical pulsar flashes like a lighthouse as its beam of radiation sweeps past our line of sight. But if this pulsar were enveloped in a cloud of debris so dense that only the most penetrating radiation, the gamma rays, could escape, it would explain why we see the high-energy signal and nothing else. The dust would absorb all the lower-energy light, rendering the object invisible in every other wavelength, a ghost visible only by its most potent scream. Another possibility is a microquasar, a small-scale version of the brilliant quasars seen in distant galaxies. This would be a stellar mass black hole or a neutron star voraciously feeding on a companion star. The infalling matter would form a hot accretion disk and launch powerful jets that collide with the surrounding space, generating the intense gamma rays. Yet, if the system were oriented in just the wrong way, with the accretion disk edge on from our perspective, the central engine could be obscured, leaving only the faint, high-energy signature of its jets as a clue. The most thrilling prospect, however, is that the orphan represents something entirely new. It could be the signature of dark matter particles annihilating one another in a catastrophic release of energy, a process long theorized but never conclusively observed. Or it might be a type of cosmic accelerator so efficient and so hidden that it defies our current categories. How many other invisible powerhouses are scattered across the galaxy, their true natures masked because they speak in a tongue we are only just learning to hear? This lopsided halo is not a smooth, serene cloud of ancient stars. Instead, its stellar population is dramatically skewed, with one side of the galaxy boasting a far richer concentration of halo stars than the other. This is not the mark of a calm, settled galaxy, but the unmistakable signature of a recent and violent feast. The asymmetry is a massive clue, pointing to a merger event that is, on a cosmic timescale, still unfolding. Imagine a quiet pond into which you toss a single large stone. The ripples spread out, but for a time, the water on one side of the impact point is significantly more disturbed than the other. The sombrero's halo is that pond, and the ripples are the stars of a devoured companion galaxy, still sloshing back and forth, refusing to settle into a symmetrical equilibrium. By tracing the density and motion of these halo stars, astronomers can effectively rewind the clock. They can trace the stellar currents backwards to pinpoint not just that a merger happened, but approximately when, and even from which direction the smaller galaxy approached. The distribution suggests the event occurred within the last few billion years, a recent trauma in the galaxy's long life. This was no minor interaction, but a full-scale assimilation that sent shockwaves through the sombrero's entire gravitational field, stirring up its outer population in a way that has not yet had time to calm. What other recent scars does this galaxy bear, hidden in the subtle motions of its farthest suns? These unusually blue clusters burn with the fierce, short-lived light of stellar youth, a stark contrast to the ancient red stars surrounding them. Their designation as BC1, BC2, and BC3 marks them as stellar anomalies, their brilliant azure hue betraying a secret. In the grand, slow-moving galaxy, these are pockets of frantic, recent creation. The blueness itself is the key. The color of a star is a direct indicator of its temperature and age. Massive, hot, young stars blaze with a brilliant blue-white light, but they are cosmic mayflies, living for only a few million years before exploding. Older, cooler stars glow with a steady red or yellow light and can exist for billions of years. For a cluster to appear this distinctly blue, it must be dominated by a large population of these brilliant, short-lived giants, meaning the cluster itself formed in a very recent burst of activity. The mystery is their location. They are not nestled within the galaxy's busy spiral arms, the traditional stellar nurseries rich with gas. Instead, they are found in more isolated, tranquil regions of the galactic disk, places where star formation should have settled into a quiet slumber billions of years ago. What cosmic trigger could have ignited such a firestorm of birth in these galactic backwaters? The most likely culprit is a shock wave, a traveling wall of pressure that swept through these quiet neighborhoods and compressed the sparse gas until it collapsed into new stars. One source of such a shock could be the death of a star. A nearby supernova explosion, like the one that created the displaced remnant we discussed earlier, could have sent a powerful wave racing through the interstellar medium. As this wave passed through a quiet cloud of gas, it would have squeezed the material, triggering a chain reaction of gravitational collapse and igniting the birth of an entire cluster of stars all at once. Another possibility involves the high-velocity clouds we encountered. Imagine one of those colossal gas projectiles slamming into a relatively peaceful region of the galactic disk. The impact would be catastrophic on a local scale, a titanic collision that churns and compresses the gas with tremendous force, creating the perfect conditions for a sudden, intense round of star formation. The blue clusters BC1, 2, and 3 are the lingering evidence of this violence, the brilliant aftermath of a cosmic accident that forced new suns to ignite. They are not planned cities of stars, but boom towns that erupted overnight, their fleeting blue light a testament to the unexpected turbulence that still stirs within the seemingly serene sombrero. A strange patch of sky within the Sombrero Galaxy flickers with a persistent, silent rhythm. This region is a microlensing event hotspot, a place where the fabric of light itself is constantly being toyed with by invisible cosmic phantoms. Here, distant stars will momentarily brighten for no apparent reason, their light intensifying before fading back to normal, all without a visible cause. These are not true changes in the star's output, but cosmic illusions created by gravity. The phenomenon occurs when a dark, compact object, like a black hole or a neutron star, drifts directly between our telescopes and a background star. Its gravity acts as a tiny, natural lens, bending and focusing the star's light, creating a temporary and precise magnification. In most parts of a galaxy, such events are rare and sporadic. But in this specific area, they are commonplace, flickering on and off like a field of silent fireflies. This extraordinary frequency points to one startling conclusion. This region is absolutely packed with invisible, massive objects. It is a cosmic graveyard of unprecedented density, a place where the dead outnumber the living. The sheer number of these events suggests a swarm of stellar remnants, a vast collection of black holes and neutron stars left behind after billions of years of stellar death, all concentrated in one area of the galaxy. How did so many of these dark relics end up clustered together? The answer may lie in the galaxy's ancient past. This could be the fossilized core of a devoured dwarf galaxy, a place that was already rich with ancient stars that have since lived out their lives and collapsed into these dark remnants. Alternatively, it might be a region where star formation was so intense and so long ago that an entire generation of massive stars was born, lived and died in the same neighborhood, leaving behind this crowded necropolis of their own cores. Each brief flash of a magnified star is a direct measurement of one of these dark objects, allowing astronomers to weigh it without ever seeing it. The collective gravity of this hidden swarm is likely subtly influencing the motions of the visible stars around it, a ghostly tug that betrays its presence. What other dark populations are hiding in plain sight, their existence only revealed by the fleeting distortions they cast upon the light of others? A vast cavity of glowing gas drifts through the Sombrero's spiral arm, a celestial soap bubble on a scale that dwarfs solar systems. This is the supershell of ionized hydrogen, an immense structure where the very air of the galaxy has been heated to a brilliant, energetic state. The shell is not a solid object, but a titanic shockwave frozen in time, a sphere of energized gas over 1,000 light-years across. Its existence points to a sustained, coordinated violence, a chain of cosmic explosions that has sculpted the interstellar landscape. The sheer energy required to create such a void is staggering, equivalent to the simultaneous detonation of dozens of supernovae. The most likely architect is a stellar association, a large group of massive stars all born from the same colossal cloud. These stars do not live long, and as they age, they blast their surroundings with powerful stellar winds, streams of charged particles flowing from their surfaces at millions of miles per hour. When these stars finally reach the end of their brief lives, they explode one after another. Their collective winds and subsequent supernova combine their force, pushing outward against the surrounding gas and carving out this gigantic, glowing cavity. The supershell is a perfect illustration of how stars, in their death, can reshape their entire neighborhood. The consequences of this colossal structure are profound and contradictory. As the expanding shell plows through the galaxy, it sweeps up the surrounding interstellar gas, compressing it into a dense, cool layer along its outer edge. This compression can be the very trigger for a new burst of star formation, as the thickened gas collapses under its own weight to ignite a new generation of suns. The supershell acts as a cosmic snowplow, piling up the raw material for future worlds. Yet, in a cruel twist, the same shell can also quench star birth. The furious radiation from the hot, massive stars inside the bubble heats the gas within, making it too energetic and turbulent to collapse. It sterilizes the interior, creating a dead zone where no new stars can form for millions of years. This single object is both a creator and a destroyer, its immense power dictating the life cycle of stars across a vast region of the galaxy. What other colossal forces are silently governing the rhythm of stellar birth and death, their influence felt across thousands of light years? A different kind of projectile streaks through the Sombrero's halo, a cosmic bullet designated only as Strange Object 30. This is not a vast cloud of gas, but a small, incredibly dense object moving at a breathtaking percentage of light speed. It is a high-velocity compact object, a lone wanderer whose very existence is a puzzle of cosmic mechanics. The sheer energy required to accelerate something so massive to such an extreme velocity is almost beyond calculation, pointing to a moment of unimaginable violence in the galaxy's past. What natural cannon could have fired such a shot? One compelling suspect is the galaxy's central supermassive black hole. A binary star system venturing too close to the gravitational giant could have been torn apart, with one star captured and the other flung away at a significant fraction of light speed. If the ejected star was already a dense remnant, a neutron star or a stellar mass black hole, it would become this very kind of compact, high-velocity fugitive. Another possibility is that we are witnessing the aftermath of a lopsided supernova explosion. When a massive star dies, the collapse of its core can be asymmetric. The resulting supernova can kick the newly formed neutron star, sending it careening across the galaxy like a cannonball fired from its own birth explosion. The object's composition, inferred from its interaction with the thin gas of interstellar space, suggests immense density, but its exact nature remains shrouded. Is it a hypervelocity star, a rare type flung from the core, or is it something darker, a stellar mass black hole ejected from its home and now roaming the void? Each possibility tells a different story about the extreme forces at play in the galaxy's heart. This lone traveler is a testament to the fact that the Sombrero's violence is not always on a grand galactic scale, but can be focused with terrifying precision on a single, speeding point of mass, a silent bullet whose trajectory was set by a cataclysm billions of years ago. Two ghostly orbs of glowing gas hang side by side in the galactic void, cosmic twins with a shared and beautiful fate. These are the paired planetary nebulae PNA and PNB, two stellar remnants that mirror each other with an almost impossible precision. Both display the same delicate spherical shells of ionized gas, both shine with a similar ethereal green hue, and both are expanding at nearly identical rates, indicating they were born at the same cosmic moment. The odds of two unrelated stars reaching this exact, fleeting phase of death simultaneously and in such close proximity are astronomically small. A planetary nebula is the final, glowing shroud expelled by a dying sun like our own, a brief cosmic bloom that lasts only a few tens of thousands of years before fading into darkness. To find two in the same stage with the same structure right next to each other is like finding two identical, intricate snowflakes landing on the same patch of your sleeve. This remarkable coincidence points to a shared life, not just a shared death. The most compelling explanation is that PNA and PNB were once a tightly bound binary star system, two stars that spent their entire lives orbiting one another in an intimate gravitational dance. They would have formed together from the same cloud of gas, matured together over billions of years, and then, as if by prior agreement, reached the end of their fuel supplies at almost the exact same time. As each star swelled into a red giant, it gently puffed its outer layers into space. The radiation from their exposed hot cores then lit up these expanding shells, creating the twin nebulae we see today. The fact that both nebulae are perfect spheres is another crucial clue. This shape suggests their progenitor stars were relatively slow rotators, allowing the gas to expand evenly in all directions without being spun into a disk or twisted into a more complex form by a companion's gravity. This implies they were likely wide binaries, orbiting each other at a respectful distance that allowed each star to die a solitary, symmetrical death, even as they did so in perfect, silent unison. These celestial twins are a rare fossil of a binary star system that survived its entire cosmic lifespan together, offering a profound glimpse into the synchronized fate of stellar companions. What other paired phenomena are hiding in the darkness, their perfect symmetry telling a story of lives inextricably linked? Amidst the millions of predictable suns, one point of light refuses to follow the rules. This object, catalogued simply as Strange Object 33, appears as a star, shines like a star, yet its hidden language of light tells a completely different story. Its spectrum, the unique fingerprint that reveals the chemical composition and physical conditions of a celestial body, is unlike anything else recorded in the galaxy. It is a cosmic anomaly that perfectly matches the theoretical profile of a dark star, a type of object that has never been conclusively found. A normal star shines because of nuclear fusion in its core, the intense pressure and heat forcing hydrogen atoms to fuse into helium, releasing the light and energy that defines a sun. A dark star, however, is theorized to be powered by something entirely different, the annihilation of dark matter. Imagine a star that burns not on a nuclear fire, but on the slow, steady decay of the universe's most mysterious substance. This would require an environment incredibly rich in dark matter, where particles and their antiparticles continuously collide and destroy each other deep within the star's heart, releasing energy that keeps the object luminous. The spectrum of strange object 33 shows the telltale signs of this exotic engine. It is too cool and red for its immense brightness, and it lacks the specific absorption lines of certain elements that are always present in fusion-powered stars of a similar age and mass. It is as if we are looking at a star that is being heated from within by a gentle, pervasive warmth, rather than by a roaring, localized nuclear furnace. If this interpretation is correct, this object is a living fossil from the universe's earliest epochs, a first-generation star that formed directly from a dense cloud of hydrogen, helium, and dark matter. It would have ignited not with the sudden flash of fusion, but with the slow, steady glow of annihilation, potentially allowing it to live for trillions of years, far outlasting any star we know. Is this solitary, strange point of light the first confirmed relic of the dark cosmos, a beacon powered by the invisible stuff that binds the universe together? This cluster of stars moves like a school of fish against the galactic current, while every other star and cluster in the sombrero rotates in a stately, predictable dance around the galactic center. This group has a mind of its own. Its collective motion, known as proper motion, is tilted and skewed, carrying it on a path that defies the simple rules of the galaxy's spin. It is as if a single neighborhood within a vast, turning city suddenly decided to march sideways down the street. This anomalous motion is a clear signal that this cluster is an outsider, a group of stars that did not form here. Its trajectory is a fossilized record of a violent introduction. The most likely explanation is that this entire cluster is the surviving core of a small dwarf galaxy that was captured by the sombrero's immense gravity billions of years ago. That ancient collision did not just tear the dwarf galaxy apart, it sent its central star cluster on a wild, careening orbit that it still follows today. The cluster's current path is the echo of that first fateful gravitational encounter, but there is another, more subtle possibility. Perhaps the cluster's strange motion is not from an external force, but an internal one. Its path could be a response to a close encounter with something massive and dark within the sombrero's own halo. Imagine the cluster passing near a dense, invisible knot of dark matter. The gravitational tug from that unseen mass could have given the cluster a precise sideways kick, altering its orbit forever without leaving a single visible trace. The stars within the cluster are so tightly bound by their own gravity that they have stayed together through this cosmic upheaval, a family of suns holding fast to one another as they journey on their rebellious path. Their coordinated motion is a testament to their resilience, and their stubborn refusal to follow the rules is our best clue to understanding the violent and dynamic history of the galaxy they now call home. What other celestial rebels are moving through the cosmos, their paths charting a history of ancient collisions and invisible forces? 3 points in the galaxy whisper in a language of pure energy. These are the methanol masers designated M1, M2, and M3, and they are cosmic lighthouses broadcasting on a specific, invisible frequency. A maser is the microwave equivalent of a laser, a natural engine that amplifies specific wavelengths of light into an intense, focused beam. On Earth, we build them in laboratories, but out here in the depths of the Sombrero, nature has created its own, powered by clouds of methanol molecules energized by starlight. The mystery is not their existence, but their location. These intense microwave beacons are classic signposts for stellar nurseries, the brilliant markers of vast clouds collapsing to form new suns. Yet when astronomers scan the regions around M1, M2, and M3, they find only quiet, empty space. There are no dense cocoons of gas, no clusters of infant stars, no infrared glow from warm dust. It is as if you found three powerful searchlights shining from a completely dark and empty field. How can these signposts exist without the city they are supposed to advertise? One possibility is that we are witnessing the very beginning of star formation, a stage so early and so subtle that it escapes all other forms of detection. The molecular cloud may have just begun to fragment and collapse, and the maser emission is the first signal of this nascent activity, a spark that flashes long before the fire is visible. Another, more haunting idea is that we are seeing the ghosts of star formation. These could be the fading echoes of a stellar nursery that was stillborn, a cloud that began to collapse but was then ripped apart by a passing shockwave or dispersed by the fierce radiation from a nearby massive star. The masers would be the last lingering signal from that failed birth, a brief and lonely memorial to stars that never were. Or perhaps the energy source is something else entirely, a hidden object like a quiet black hole or a neutron star whose radiation is exciting the methanol in just the right way to create these precise beacons. What other invisible catalysts are at work in the galaxy, their presence revealed only by the way they make the darkness sing? Deep within the galactic disk, a binary star system communicates in a frantic, stuttering code. This is Strange Object 38, an X-ray binary whose emissions are punctuated by strange, almost rhythmic pulses known as quasi-periodic oscillations. The compact object, either a neutron star or a black hole, is locked in a tight, vicious dance with a normal companion star, relentlessly stripping gas from its outer layers. This stolen matter does not fall directly onto the predator, but spirals inward, forming a superheated, whirling disk of plasma called an accretion disk. It is from the extreme inner regions of this disk that the bizarre oscillations originate. The pulses are not perfectly regular like a clock, but they are not random noise either. They are quasi-periodic, flickering in a narrow range of frequencies, like a candle flame guttering in a drafty room. This rhythmic stutter is a direct probe into the most violent gravitational environment imaginable. The physics behind these oscillations is a window into the very edge of spacetime. One leading theory suggests they are caused by blobs of hot gas orbiting at the innermost stable circular orbit, the final point where matter can still travel in a circle before it is irrevocably pulled inward. As these blobs whip around at nearly the speed of light, they create hotspots that flash at us with each revolution, their frequency revealing the precise strength of the gravitational field. Another idea posits that the entire inner accretion disk is vibrating, resonating like a struck gong. The immense gravity of the central object causes the disk to pulsate in specific modes, creating the observed oscillations. The exact frequency of these pulses is the key to unlocking the system's deepest secret, the true nature of the compact object itself. If the oscillations settle into a very specific high-frequency pattern, it could indicate the presence of a neutron star whose solid surface and powerful magnetic fields can impose a rigid structure on the infalling matter. A lower, more chaotic set of frequencies might point toward a stellar mass black hole, where the lack of a physical surface allows for more complex and turbulent behavior in the accretion flow. This single, flickering X-ray source is a natural laboratory for testing the laws of physics under conditions we could never hope to recreate on Earth. its quasi-periodic heartbeat echoing the fundamental rhythms of gravity itself. A slow-motion cataclysm is unfolding at the very edge of the sombrero. Strange Object 39 is a colossal structure caught in the act of being devoured, a star cluster or a small galaxy stretched into a brilliant, tearing stream as the galaxy's gravity pulls it apart. This is not a relic of the distant past, but a live capture happening right now, a feast we can witness in real time. We are watching an intergalactic tramp, a wanderer that ventured too close, now being slowly dismantled and absorbed into the larger galaxy. The process is both beautiful and violent. As the object falls inward, the difference in gravity between its near side and its far side becomes overwhelming. This tidal force stretches it, pulling stars from its body like cosmic taffy, scattering them into long, luminous arcs that trace its death spiral. These streams of stars are not just a spectacle, they are a direct measurement of the sombrero's gravitational field, revealing the distribution of both visible and dark matter that grips the victim. The effects ripple through the galaxy. As this new material rains down onto the sombrero's outer disk, it acts like a stone thrown into a pond. The incoming stars and gas create waves of density that ripple through the galactic plane, compressing the existing interstellar medium. This compression can trigger spontaneous bursts of star formation, igniting brilliant blue clusters in otherwise quiet neighborhoods, a secondary creation born from primary destruction. The intergalactic tramp is seeding the galaxy with new suns even as it dies. This ongoing accretion also stirs up the sombrero's halo, adding to its lopsided structure and providing fresh fuel for future generations of stars. It is a stunning reminder that galaxies are not static islands, but dynamic, ever-changing ecosystems, growing by consuming their smaller neighbors. How many other cosmic wanderers are currently falling into the sombrero, their silent demise shaping the galaxy we see today? Wrapped around the galaxy like a faint cosmic scar lies a ghost of a former self. This fossil spiral arm is a relic structure, a pale echo of the galaxy's vibrant disk that has been stretched and dimmed over billions of years. It is not an active part of the current spiral, but a dying ripple in the stellar sea, a remnant from an era when the sombrero looked entirely different. Its very existence provides a living timeline, a window into the galaxy's dynamic and often violent evolution. How does a bright, star-forming arm become such a pale ghost? The transformation begins with a gravitational disturbance, a close encounter with another galaxy, or even the collective gravitational pull of the orbiting dark matter halo can send powerful density waves rippling through the galactic disk. These waves are what create the classic spiral pattern, compressing gas and triggering the birth of bright blue stars that outline the arms. But when the disturbance passes, the wave moves on, leaving behind the stars it helped create. The most massive, brilliant stars live fast and die young in supernova explosions, fading from view in just a few million years. What remains are the longer-lived, older and fainter stars, the red dwarfs and sun-like stars that can shine for billions of years. These stars continue to orbit, but without the compressing wave to keep them densely packed, they slowly drift apart, their collective glow dimming into a faint, ethereal stream. This fossil arm is that aftermath, a stellar backbone from which the bright flesh of young stars has long since faded. By studying the age and motion of the stars within this structure, astronomers can effectively rewind the clock. They can determine when this arm was last a vibrant, star-forming region, and what event might have triggered that period of intense creation. It is a fossil record written not in stone, but in the slow, patient light of ancient suns, telling the story of a younger, more turbulent Sombrero Galaxy. What other ghostly structures from its past are still drifting through its halo, their stories waiting to be decoded from their faint, steady glow? 2 points of light in the Sombrero Galaxy wrote their own brief, brilliant stories and then vanished. These are the unidentified transient objects TO1 and TO2, celestial events that flared with incredible intensity for a short time before fading back into the darkness from which they came. Their nature remains one of the galaxy's most compelling open cases. A transient is any astronomical object that is not permanent and constant in its brightness, and these two were among the most enigmatic. They appeared suddenly, shone with the light of millions of suns, and then disappeared over a period of months, leaving behind only questions. The immediate suspicion for any such brilliant flash is a supernova, the catastrophic death of a massive star. Yet, the light signatures of TO1 and TO2 did not perfectly match the known patterns of any common type of supernova. Their light curves, the precise graph of how their brightness changed over time, were slightly too fast, or their colors were a little off. This suggests they may have been supernova occurring in unusual environments. Imagine a star exploding deep within an extraordinarily thick cloud of dust. The surrounding material would absorb and reprocess the initial flash of light, changing its color and stretching out its decline, creating a distorted version of a familiar event. Alternatively, the progenitor star itself could have been a rare type, perhaps one with an unusual chemical composition that led to a strange and unique death throe. A more exotic possibility is that these were tidal disruption events. This occurs when an unlucky star wanders too close to a black hole. The black hole's immense gravity stretches the star, pulling it apart into a long, thin stream of gas in a process called spaghettification. This gaseous debris then swirls into a hot, temporary accretion disk around the black hole, glowing brilliantly with a final burst of light as it is consumed. A tidal disruption event would flare brightly in the galactic core or in the dense central bulge, precisely where a lone black hole might lurk. The light from such an event has its own distinct signature, different from a supernova's nuclear furnace. Could TO1 and TO2 have been the final screams of stars shredded by invisible, intermediate mass black holes scattered throughout the galaxy? Or were they something even stranger, a type of stellar explosion we have not yet named, a new chapter in the physics of stellar death written in a language we are only beginning to understand? Their brief lives remind us that the sombrero is a dynamic stage where the most dramatic acts can be fleeting, leaving us to piece together the plot from a fading glow. This star is a cosmic alchemist forging diamonds in a hurricane. Strange Object 43 is a Wolf-Rayet star, a rare and spectacular class of stellar giant in its final frantic death throes. Unlike the steady glow of our sun, this object is a furious maelstrom, expelling its own atmosphere into space at millions of miles per hour. Its defining strangeness is an atmosphere impossibly rich in carbon, the fundamental building block of life. This is not a gentle old star, but a massive, short-lived behemoth that has burned through its nuclear fuel with reckless speed. It has already fused the hydrogen in its core into helium, and then the helium into carbon. Now, through a combination of intense heat and powerful stellar winds, it is violently ejecting that freshly forged carbon into the galaxy. Imagine a colossal, unstable furnace blasting clouds of diamond dust into the void. That is the essential nature of this object. Its lifespan is terrifyingly brief. While a star like our sun will shine for billions of years, a Wolf-Rayet star lives for only a few million. It is a stellar firework, a brilliant flash destined to end in a supernova explosion of unprecedented force. This dramatic end is precisely what makes it so crucial to the galaxy's evolution. In its final moments, the star will detonate, scattering all of its newly created heavy elements across interstellar space. The carbon it has been spewing for its entire short life, along with even heavier elements forged in the supernova itself, will be flung far and wide. This enriched material will eventually mix with clouds of primordial gas, becoming the raw ingredients for new star systems, rocky planets, and perhaps even the chemistry of life itself. We are all, in a very real sense, made of stardust, and stars like this one are the primary factories for the carbon in our bodies. This single, turbulent star is a crucial link in the cosmic cycle of death and rebirth, its violent winds seeding the future with the very elements of existence. A subtle tremor in the cosmic fabric leaves its signature on the stars. Strange Object 44 is not a single thing you can see, but a pattern, a configuration of stellar remnants whose positions and motions hint at a recent violent collision. This region of the Sombrero is a gravitational wave source candidate, a place where the echo of a catastrophic merger might still be rippling through spacetime. The evidence is written in the orbits of the objects left behind. Astronomers have pinpointed a tight group of black holes and neutron stars, the dense corpses of dead stars, all moving in a way that suggests they were recently part of a much more complex system. The most compelling scenario is that two of these dark remnants, locked in a final, fatal dance, recently spiraled into each other and merged. Before the collision, they would have orbited one another at incredible speeds, their immense mass churning the spacetime around them like spoons in a thick fluid. This motion would have generated ripples in the very fabric of the universe, gravitational waves that propagated outward at the speed of light. These waves are not light or sound, but literal stretches and compressions of space itself. While the merger itself is long over, the telltale arrangement of the surrounding objects acts as a cosmic crime scene, pointing back to the event. The surviving remnants in the area appear to have been gravitationally nudged, their path slightly altered by the sudden, catastrophic loss of mass and the immense burst of energy released when their two neighbors became one. It is like finding a group of boats all bobbing on a calm sea in a specific, synchronized pattern, suggesting a large vessel has just passed by, its wake still subtly affecting them. Future observatories designed to listen for these spacetime ripples could one day tune into the specific frequency of such an event. Confirming this candidate would open a new window into the Sombrero, allowing us to hear its most violent moments and weigh its invisible dead with unprecedented precision. What other silent collisions have shaped this galaxy, their history written not in light but in the twisted paths of the survivors? Suspended high above the Sombrero's glowing disk, three isolated clouds drift in the silent darkness. Designated GLC-1, GLC-2, and GLC-3, these are not star-forming regions but vast reservoirs of cold, neutral hydrogen gas, chilling in the galactic backwaters far from the plane where such material should exist. Their presence at such high latitudes is a gravitational puzzle, challenging our understanding of the galaxy's structure and history. The central debate revolves around a simple but profound question. Are these clouds primordial leftovers from the galaxy's formation, or are they the scattered debris from a long-forgotten cosmic collision? The primordial hypothesis suggests these are fossil clouds, ancient pockets of gas that never collapsed to form stars. They could be the last untouched relics of the raw material from which the Sombrero first coalesced, preserved for billions of years in the quiet of the halo. In this scenario, they are cosmic time capsules, holding a chemical record of the universe's composition before multiple generations of stars polluted it with heavier elements. Finding such pristine gas would be like discovering a pocket of the Earth's original atmosphere trapped in a glacier. However, their isolated positions and specific velocities make a compelling case for a more violent origin. The alternative theory paints a dramatic picture of galactic cannibalism. These clouds could be the final, gaseous tatters of a dwarf galaxy that was torn apart by the Sombrero's gravity. As the smaller galaxy was shredded, its stars were pulled into the tidal streams we've already encountered, while its diffuse hydrogen gas was strewn across the halo, settling into these discrete, high-altitude clouds. Their current locations and motions could be the final act of that ancient destruction, the last few pages of a story that began with a cataclysm billions of years ago. Or perhaps they are not interlopers at all, but material that was violently blasted out of the Sombrero's own disk. Intense episodes of star formation in the past could have generated powerful supernova winds, blowing colossal bubbles of gas clear out of the galactic plane and into the halo, where they condensed into these cold, lonely clouds. Each hypothesis leaves a different chemical fingerprint, and astronomers are now searching for that telltale signature in the faint radio whispers of this neutral hydrogen. Are we looking at the galaxy's original building blocks or the scattered ashes of its last major meal? Even the most chaotic stellar deaths can produce structures of breathtaking geometry. Among the 50 strange objects, one nebula stands out for its sharp, almost artificial appearance, a crimson structure so distinct it echoes a famous enigma within our own Milky Way. This is the red rectangle analog, a glowing cloud of gas where two dying stars perform a cosmic ballet, painting the void with precise lines of intense red light. Its vivid color comes from a specific type of carbon-rich dust, illuminated by the fierce ultraviolet radiation from the central stars. This dust is not scattered randomly, but is funneled into two opposing conical lobes, creating the illusion of a vast, hollow rectangle when viewed from our perspective. The mechanism behind this perfect shape is as elegant as it is rare. At the heart of the nebula lies not one, but two aging stars locked in a tight gravitational embrace. One has already exhausted its nuclear fuel and is shedding its outer layers, while its companion influences the outflow in a critical way. The two stars orbit each other so closely that they are surrounded by a thick, dense torus of dust, a cosmic belt that constricts the expanding gas. This belt acts like a nozzle on a garden hose, channeling the ejected material into two powerful jets that shoot out from the poles of the system. From our distant vantage point, we look directly down one of these cones and see the edges of both, tracing the sharp, rectangular outline. This entire, beautiful structure is a fleeting phenomenon, a celestial flower that blooms for only a few thousand years before the central stars complete their transformation and the nebula dissipates into the interstellar medium. It is a stunning example of how binary stars can sculpt their own death, turning a potentially chaotic explosion into a work of profound and temporary art. How many other such geometric wonders are hidden in the galaxy, their perfect forms waiting to be seen from just the right angle? Even the darkest voids between the stars are not truly empty. A faint, pervasive light fills the vast spaces of the Sombrero Galaxy, a ghostly luminescence that should be a simple echo of all its suns, but this diffuse light is not behaving as it should. Its color is slightly too red, and its waves are polarized in a strange, uniform direction, as if every particle of dust is mysteriously aligned. This is not the gentle glow of distant, unresolved stars. It is a whisper of something else entirely, a signature that points to a hidden population within the galaxy. The light itself is a cosmic crime scene, and its anomalous properties are the clues. The unusual redness suggests the dust grains responsible are far larger than the typical interstellar soot found in most galaxies. Imagine the difference between fine, floating cigarette smoke and a cloud of coarse, red sand. Each scatters light differently. These could be vast clouds of millimeter-sized particles, more like tiny pebbles than fine dust, perhaps the ground-up remains of countless comets or the collision debris from a primordial asteroid belt on an unimaginable scale. Even more puzzling is the polarization. For light to become polarized, the particles it scatters from must be aligned, like countless tiny compass needles all pointing the same way. This requires a coordinated force, typically a magnetic field threading through the galaxy. But the pattern here is too strong, too organized. It hints at a magnetic field of surprising power and coherence, one that has swept through these dark regions and neatly arranged every microscopic grain in a single, silent direction. Or perhaps the light is not from dust at all. Could it be the collective glow of countless ancient, cold stars, so faint and so spread out that they blur into a single, reddish haze? These would be stellar ghosts, the burned-out embers of the galaxy's very first stellar generation, now drifting alone in the dark, their feeble red light summing into this mysterious background. Each explanation paints a different picture of the sombrero's hidden anatomy. Is it filled with strange, coarse dust from a forgotten era of planetary formation, or is its darkness threaded with the faint, dying breath of its earliest suns? This anomalous light is a reminder that what we see is only a fraction of what is truly there, and that even the emptiness between the stars holds its own profound secrets. The final object on our list defies the very idea of a border. Strange Object 50 is a flicker of evidence for an impossible world, a planet that may exist not merely in another solar system, but in another galaxy entirely. The method of its supposed detection is a testament to human ingenuity, relying on a cosmic alignment of almost zero probability. Astronomers observed a distant star in the sombrero momentarily brighten, not from its own activity, but from the subtle gravitational lensing effect of an unseen object passing directly in front of it. This phenomenon, called a microlensing event, acts as a natural magnifying glass, briefly amplifying the star's light. The data from this event, however, contained a tiny, secondary blip within the main brightening peak. This minuscule anomaly is the heart of the controversy. It suggests the primary lensing object, likely a star, was not alone. The secondary blip perfectly matches the signature of a smaller, orbiting body, its own tiny gravity adding a faint, extra flicker to the light. The calculated mass of this secondary object places it squarely in the planetary range. The challenges of this detection are staggering. The star, the potential planet, and the lensing object are all tens of millions of light years away, all blurred together into a single, unresolved point of light. We are inferring the existence of a planet from a single, unrepeatable fluctuation in a distant sun's brightness, a signal buried in immense noise. If this interpretation is correct, the implications rewrite the rules of planetary science. It would mean planets are not just common in our galactic neighborhood, but a fundamental and universal byproduct of star formation, scattered across the entire universe. It would mean the Sombrero Galaxy, with all its black holes and stellar ghosts, also holds rocky worlds silently orbiting alien suns. This candidate, more than any other object, stretches our reach across the intergalactic void, forcing us to wonder how many other impossible worlds are waiting in the dark, their presence hinted at only by the faintest distortion of a faraway light. The very idea of finding a planet in another galaxy hinges on a celestial alignment of impossible perfection. To detect this candidate, astronomers relied on a phenomenon called gravitational microlensing, a natural quirk of the universe where gravity itself bends and magnifies light. The process begins when a foreground object, like a star or even a black hole, drifts almost perfectly in front of a much more distant background star. The foreground object's gravity warps the space around it, acting as a temporary lens that focuses the background star's light, causing it to brighten in a specific, predictable pattern. For a fleeting moment, that distant star becomes thousands of times brighter, allowing us to see it across an ocean of dark space. Within that brightening curve, a tiny, secondary flicker is the only hint of a planet. This blip is the gravitational signature of a world orbiting the lensing star, its own minute gravity adding a subtle wrinkle to the magnification event. The entire detection is a triumph of statistics and patience, relying on a 1 in a million alignment that may never happen again for the same star. It is like trying to spot a single firefly momentarily illuminated by the headlight of a car on a distant, dark highway, all while you are standing miles away. The conditions on such a world are almost beyond imagination. This hypothetical planet orbits a star that is itself a wanderer, likely flung out from its original birthplace during some ancient galactic collision. Its sun would be a faint, old star, and the planet itself would be a frozen, barren rock, bathed in the feeble glow of its parent sun and the dim, collective light of an entire galaxy. There would be no day and night as we know it, only a perpetual, star-filled twilight with the majestic band of the Sombrero Galaxy arching across its black sky. The existence of this candidate shatters the assumption that planets are bound to their home galaxies. It suggests that planet formation is a universal and robust process, one that can occur even in the most chaotic environments around stars that have been exiled from their stellar nurseries. If planets can form and survive around stars adrift in intergalactic space, then the total number of worlds in the cosmos must be vastly greater than we ever dared to dream. How many other orphan planets are drifting in the darkness between galaxies, their existence unknown and perhaps forever unknowable, silent testaments to the sheer abundance of worlds in the universe? From this galactic menagerie of 50 cosmic anomalies, a single profound truth emerges. The sombrero is not defined by any one mystery, but by their stunning collective diversity. Each strange object, from the sleeping supermassive black hole to the potential intergalactic planet, is a unique voice in a grand cosmic chorus. The ancient, metal-rich star tells a story of the galaxy's violent birth, while the warped dust lane and the lopsided halo chronicle its turbulent adolescence. The high-velocity clouds and the runaway star cluster are testaments to ongoing violence, and the orphan gamma-ray source whispers of processes we have yet to name. Together, they reveal a galaxy that is not a static portrait, but a dynamic and ever-evolving ecosystem. It is a place where the invisible hand of dark matter sculpts the paths of stars, where stellar life and death seed the future with the ingredients for worlds, and where the very laws of physics are tested at their limits. This collection of 50 enigmas demonstrates that galactic evolution is not a simple, linear path, but a complex tapestry woven from countless threads of chaos, creation, and destruction. The Sombrero Galaxy's unique character is forged in the interplay between its dark heart and its rebellious outliers, between its ancient fossils and its brilliant, fleeting newborns. We have journeyed past black holes that defy explanation and stars that burn with impossible fuel. We have traced the ghostly echoes of long-dead galaxies and witnessed the potential birth of worlds beyond our own. Now we turn the final question to you. Among these 50 cosmic wonders, which one captured your imagination the most? Was it the silent, diamond-forging fury of the Wolf-Rayet star, or the haunting, triple-image illusion of the background quasars? Perhaps it was the sheer audacity of a planet existing in another galaxy. Share your favorite strange object in the comments below, and if you enjoyed this journey to the edge of the known, subscribe for more explorations into the universe's deepest